What's up, guys? It's your boy Matt back again on WeldTube today at the one and only South Coast Welding Academy in Houston, Texas. Got something special for you guys today. Some titanium tube, exhaust tubing like you'd see on a Lambo, McLarens, exotics like that, stuff the rich guys like. So I'm giving you guys a little insight on what I like to do. I do a lot of exotic work like this, so the least I can do is bring it to y'all. Just want to remind you guys, weldlife.com, get on the St. Jude campaign with us, try to save a couple of lives, because parents that have kids with cancer, medical bills are the last thing they should have to worry about. They just got to worry about getting their kid back out and playing and being a kid. So check out weldlife.com, use Worry Welding TX, get yourself 10% off. All right, guys, like I said in the intro, I'm going to do a titanium tube for you guys today. I'm going to do two of them. The first one I'm going to do is just going to be like you would see in a traditional speed shop. Most of the time you're going to have a bunch of joints, pie cuts, stuff like that. Today we're only going to do one joint because it's a training video. So have it chucked up in my positioner just to hold it for us, and I'm going to use my CK Flex Lock torch. Okay, this is a great, love this torch for anything automotive. You can flip the head around wherever you need it to be. It's great on roll cages, automotive type applications. That's really the only time I use this guy. I wouldn't use it for any heavy amperage or anything, but today we're only using about 40 amps or so, so it's perfect application. Number 14 Ferret cup. It's the biggest cup I personally have on hand, so when you're using titanium or any really exotic alloys, you need a bunch of argon coverage, so the bigger blanket of argon we can get, the better we're gonna be. The reason I want to do two welds is to show you guys the difference on actually what the argon's gonna do for us. So the first one we're gonna do with just this cup, like I said, you can outrun your argon is basically what I'm trying to say. So for instance, I said it's a number 14 cup. Cups are measured in 16ths, so 14/16 or 7/8 of an inch. So technically we can weld about half the diameter of our cup, so 7/16. So we'll be able to weld about a half of an inch at a time, and we're gonna have to stop because you're gonna outrun your argon blanket and you're gonna start seeing bluing on your tube, which a lot of exotic car guys like that. They're gonna anodize it anyway when we're done to make it purple, but I like all my welds to be chrome no matter what, so I don't want any color in it at all. So we're gonna stop every half inch, let the post flow go, weld another half inch. It takes forever. So for instance, that's probably gonna take us 8 or 9 minutes per weld. If these were pie cuts in trying to get a 90-degree turn or something like that, think of 10 minutes per weld. It might take you over an hour to weld up one elbow. Where with the turntable positioner and a trailing shield like I have here from TiTech Industries, great trailing shield attaches to your torch, I can knock out a weld in 3 minutes. I don't have to stop. So for productivity reasons, it just makes sense. They're reasonably priced, and considering the cost of the titanium, it's a cheap insurance to make sure it's perfect every time. You don't have to worry about it. Like, sure, if you have some bluing there, you can come back and get rid of it, that's fine, but why even waste your time? Because if you're doing an exotic exhaust, sometimes these cars, it's $10,000, $12,000 for an exhaust system to be custom made like this. So you're bidding that job. So from there, how fast you get it done is how much money you're gonna make. It's not an hourly gig. So using the trailing shield, couple $100 investment, it's gonna put a lot more money in your pocket. So you'll see the difference between the two, and hopefully you guys get something out of it. So we're gonna get set up a little bit, and we'll be right back, start burning some rod. See you soon. All right, guys, we're gonna get this thing tacked up, okay? So I just have this piece of tape on the top to hold me in line. It's just taped together, slammed and jammed, no gap. Got the machine on 44 amps. I'm using the pedal just so I can slope up and slope down, and 40 cubic feet per hour on the torch, and 25 cubic feet per hour coming to the purge, okay? So like I said, titanium loves argon, so it sounds crazy. It's like a fire hose of argon coming out of here, but that's what we need for this application. So we're gonna go ahead and tack it up. Just fusion tacks, no filler rod. So bear with me, get this thing tacked up, and then we'll start welding it out, all right? Got a 15-second post flow. Running pretty low amps, so 15 seconds is plenty. Some guys like to run more, but to me that's almost a waste. So 15 gives you a perfectly silver tack. I'm gonna use the rotator here to speed us around. I'm gonna go ahead and tack it at 180 degrees off of each other. Go ahead and put another fusion tack here. Just make sure you don't have any high-low. You want to make sure if you need to adjust it, now's the time. Make sure you hold your torch there for the whole post-flow cycle. So I know a lot of times people think about titanium and they kind of get freaked out a little bit just thinking about, oh, titanium must be hard to weld, this and that. If you break it down to the basics, you know, you have a heat source, you have a molten puddle, and you have a filler material. If you can think of welding like that, everything is basically the same, okay? We're just melting metal. We're not going to the moon, all right? If you can weld stainless steel, you can weld titanium. Just cleanliness and argon coverage is really the only big differences. Besides the one kicker is that titanium is sticky, all right? And it's hard to explain until you've welded it, but if you're not super precise with your filler material, it will stick to the tube and almost glue itself down. So you really gotta be on top of it when you're doing your tiny little dabs, because you'll probably see it in the video. I'm sure I'm gonna stick my filler rod, so you'll see. But that's really the biggest difference that I can tell between welding the two. It's definitely titanium is sticky. All right, so like I said, we can only weld about half the diameter of our cup. So I'm not gonna measure this thing out and lay it out. So I'm just gonna go by dabs. So I'm gonna stop about every 8 dabs, and that should be about a ½ inch or so. So I'll stop every 8 dabs, we'll see what it looks like. More than likely, every start and stop, you're gonna see a blue spot from the lack of argon coverage. So let's work our way around this thing. I'm only gonna use a positioner to turn it after each weld. It's not gonna be turning while I'm welding, okay? Like I said, we're doing a 3-inch titanium tube, 0.47 wall, less than a 1/16 of an inch thick. It's pretty thin. Very typical on, like I said, motorsports applications, even aerospace applications. So for today's weld, we're using filler material. We're not fusing it like I did on the sanitary tube video. We're using CP1 titanium filler rod. It's 0.39 diameter. It's pretty thin. It's what I use for pretty much all my titanium exhaust jobs. Get it Tacking Industries right out of Austin, so right here in our beautiful state of Texas, as well as the tubing. Thanks to Tacking, they supply me with everything for my job. So let's get rocking and rolling. This is the one without the trailing shield. You're definitely going to notice a big difference in quality as well as the speed of the weld. So without further ado, let's dive into this guy. There's that sticky filler rod I was telling you about. And rotate. You can already see a brown spot on the back side of the first weld. Rotate. Again, I'm doing 8 dabs at a time, trying to keep as much gas coverage as I can. Tiny little dabs. You don't want to force feed the puddle at all. You want it to kind of sink, and you just want to keep it full, okay? Doing it this way also, all the post-flow stops, it's really going to kill your bottles quick. So I'm telling you, trailing shield is where it's at for a lot of reasons. A lot of things come into play with doing this kind of stuff, especially coming down to a building that I haven't welded in before this process anyway. Being a school, there's a lot of people here welding, pulling off the panels. So if one day, when you're setting this kind of stuff up, if one day, you know, there might be 20 people welding, one day there's 40 people welding, the machines are gonna run differently. So you never really know what you're gonna walk into. You always wanna do a test run. Another big thing is ambient temperature, humidity. We're in Houston, we're basically living underwater. So all those things come into effect on exotic materials. So you don't really know what you're going to get into. I always have small drops laying around before I start a job just to make sure I can get set up and it's going to be how I need it to be before you jump into it. This tubing is about $100 a foot. I mean, you go through it quick. So the last thing you want to do is set up on a job that's, you know, a big paying gig, and your first weld out of the gate, you know, you smoke the tube or you mess it up. So, you know, there's all kinds of factors that come into play more so on these exotics than it would on your typical stainlesses and mild steels and stuff like that. So just one more thing to think about when you jump into this. And you can get a small sample kit for about $25. Comes with some pie cuts, a couple pieces of sheet metal, and some filler metal. If you want to go to Tacon.com, you can get a little sample kit. It's great for students that want to try it. A lot of schools aren't going to spend the money to get titanium for you guys to play with. So go to Tacon Industries, get yourself a little sample kit. Comes with everything you need, minus the machine and argon, obviously. But if you just want to take a crack at it and give it a shot, it's a good place to start. You can obviously see the spots on every start and stop I've had so far, so you kind of get the hint. You don't want that. It's okay for this type of application, but anything critical, any aerospace type stuff, that would be a big no-no. But for just cars that are going vroom and backfiring, go wow, 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 you know, it's pretty okay. But all right, guys, so like I said before, with having the smaller cup, you can only go about half the diameter of your cup. So if you look on the tube, you can see the rings, the half circles. That's actually the diameter of my cup when I was starting and stopping. So you can see each little ripple like a fish scale. And that was only welding about a ½ inch at a time. So this thing took forever and a day, all right? Does it look okay? For a motorsports application, absolutely. That would get by. Would it be okay for me or in my shop? No. But for your run-of-the-mill everyday guy on an exhaust system, they'd probably be happy with this. If you want something that's going to go to the moon, that's where we step it up a little bit, and we're going to use our TiTech Industries 3-inch trailing shield. Okay, it's going to give us like a third of the pipe's going to be shielded at all times. So if done correctly, this whole entire weld should be completely chrome looking. Okay, there should be no color at all, not even a straw color, which is acceptable in most industries. Straw is like a light tan. That's about the only color that's really allowed in titanium. If you weld anything, it's got any blues or purples or anything like that, it's a no-go. It's an instant fail. So chrome to straw is what you're looking for. I personally like no color at all. It's just one shiny, and this is what I use to get those results. To get those results. Damn it. So like always, I use my TIG Aesthetics purge plugs. And if you own these or you're thinking about getting them, if you pop the screen out, they come with the screens out. But inside here, there's like a 1/4 inch gap. Okay, I don't know if you can see that. There's like a 1/4 inch gap between the back and where the screen goes in the slot. So if you're running, it comes with these little metal tubes. If that gets pushed all the way in against this little screen, it's not going to diffuse as well. So I like to take some 316L stainless steel wool. I pack it in there, and it adds a little bit better distribution of your argon, a little smoother stream. The last thing you want inside your tube is turbulence. So just throw some stainless steel wool in there. It'll really diffuse it that much better, and I really have noticed better results by doing this. So just a little tip. Pop this back in, and we're ready to rock. Step it up. All right, so that's ready to go. All we did is wipe that down with some acetone, and that'll be ready to go. Let's get our torch ready, okay? All right, so last time on the last weld, we used my Furic 14 cup, 7/8 diameter. Works great, but you gotta stop a lot, takes forever. For stainless steel and stuff like that, these are fabulous. But on titanium, you just need more of a blanket, okay? So I'm actually going back to my jumbo gas lens, like what I would use on any kind of piping, heavy wall type stuff. Jumbo gas lens, number 12 cup, okay? So it's actually a little bit smaller cup. Still using a 332nd tungsten. Go ahead and get that in there. Number 12 cup, okay? And this cup, on these trailing shields, it's almost like they were made to use these cups. They fit perfect. Okay? Now how the trailing shield works, has a hose clamp on the front. Pretty simple, okay? So it comes right in on your cup. Cup slips right through, and then it's just a thumb screw. Don't crank down too hard. You don't want to break your silica cup, but you know, squeeze it on there pretty good. It's nice and tight. It's not going anywhere. This is going to wrap right around our tube, okay? It's going to sit right on our tube, and it seals that whole entire surface full of argon. So we're going to be, you know, 2/3 of the way around this tube before the beginning of our bead ever sees oxygen or any atmosphere whatsoever. So it's almost impossible for the weld to not be silver, okay? It's a great investment. So if you're into the tube game or anything like that, it's definitely pick them up. These are great. Still 40 cubic feet per hour of argon going to the torch, and I have 30 cubic feet per hour going to the trailing shield, and I have a 25 cubic foot per hour purge going inside the tube. So 3 different bottles of argon for one weld. It's kind of crazy, but it's what you got to do. It's part of the game. You can see I lined up the seams pretty closely, so like I said, if there was any ovaling on the tubing, you'll still get them nice and tight, because they should be, if they are out, they're going to be out the same direction. So that's our last tack. 4 tacks around the tube. Let's do one more quick wipe down with acetone, and then we'll go ahead and light up on this guy and burn it out. With the speed settings, how I have them, it should only be a 3-minute weld, so it's going to go pretty quick. So always try to use a lint-free rag. Paper towels like to leave a residue and they get caught up inside the small seams, so nice lint-free rag like you buy to wash your car or whatever, that's what I like to use. All right. So now that that's wiped down, it's important, don't touch it. You don't want to get the oils from your skin on it. Do a quick cold knuckle check. Got a good purge. Ready to light this fire. All right guys, that's how I weld out a titanium tube. It's not too difficult, just takes a little bit of practice, and you guys can do it too. It's really nothing to it. We're just melting metal, we're not going to the moon. So get yourself some, like I said, Tacking Industries, get yourself a sample kit, practice up on it. It's really not that bad. You might impress yourself actually. So until next time guys, Matt, Warrior Welding TX, check out weldlife.com, pick yourself up some gear, and again, please support the St. Jude cause. We need to save these kids, and kids shouldn't be sick and parents shouldn't have to worry about paying bills. So get on the St. Jude kick, help these people out, get these kids back out. So until next time guys, we'll holler at you later, all right?